Hi, welcome to the video solution for past paper. This is Edexcel IAL Physics Unit 1, specimen paper for new specification 2018. So let's start. Question number 16. A ball is thrown upward with a velocity v1. The velocity time graph of initial part of the motion is shown. The time of contact with the ground can be taken as negligible. Okay, velocity time graph of a bouncing ball, a typical graph. Assume that resistive force are negligible. Describe the motion of the ball between time 0 and t3. In this type of question, especially for bouncing ball, the most important concept that you will have to keep in your mind is direction of the motion. Remember, when if you see the bouncing ball, you have a ground and a ball is either falling down or maybe going up. So if this is the ball going up and then it reaches at some height, and after that it start falling down and then it's bounce. So there are some points that you need to keep in your mind. Number one, direction of the motion. So you will have to consider either upward direction positive and downward negative, or upward negative or downward positive. So what I am doing is I am considering uh, the upward direction positive. I will write here upward direction positive, and if ball is falling down, I will consider it as that negative. So what happened if you see, when we give some initial velocity v1 here, and using this initial velocity, ball starts moving upward in positive direction. So it is moving upward with positive direction, but velocity will be decreasing at every point, and as soon as the ball reaches at the height here, the velocity will be zero. And this motion, this one-sided motion, is shown in the graph from v1 till t1. So this portion of this graph shows the ball is moving upward, but with decreasing velocity, and eventually it reaches at some maximum height where velocity becomes zero. So at t1, velocity ball is at maximum height, and now after that, ball starts falling down. That means velocity starts increasing, but it is increasing in negative direction and increasing with the same rate because it is free fall motion. It is free fall motion, so there is acceleration due to gravity throughout, whether the ball going up or falling down. So when the ball is falling down, the velocity is increasing with the same rate, but in opposite direction. So instead of going up, velocity increasing, we keep going in the same in the with the same gradient in negative direction. And here, this is the point where ball reaches the ground. So ball is reaching the ground with some maximum speed. So this is basically time t1 here, and this is the time t2. And we are ignoring, as say that they ignore or negligible time taken from the ground. So we are ignoring, and we assume that ball instantly bounce off and then start moving up. So from t2, ball is again moving up, but velocity will be decreasing. So this motion, this is still at t2 because it is bouncing from the ground. So at t2 it is bouncing upward. So t2 here, and then it is moving upward. So this graph is showing that the ball is going up, but velocity is decreasing and decreasing and decreasing, eventually finally reach at the height where again velocity becomes zero at t3. So that's the behavior of bouncing ball that you need to explain in this answer. I hope that uh, you you were with me. That's how you can write. Part B, draw an acceleration time graph. on the axis below for motion of the ball from time equal to 0 to time t3. You can ignore any temporary change in the acceleration on impact with the ground. So we are ignoring any time change of impact. So remember, if you're ignoring time change of impact, that means we say that whether the ball is going up or falling down, it is free fall motion. And free fall motion, remember, for free fall motion, the acceleration is always minus g, meaning minus 9.81 meters second minus 2. It doesn't matter it is going up or going or falling down. Remember, there is a confusion that some students think that g is positive. G is positive plus 9.81 if ball is falling down, and G is negative 9.81 if ball is going up. This sign convention we use only for the sake of calculation. If you use equation of motion and you are using value of g for the sake of calculation, then we say that the ball is falling down or coming up. That's we decide the sign convention. But in reality, acceleration in terms of vector always remains in negative direction. So value of a is always minus 9.8. So for this from 0 to t3, the acceleration will always be minus 9.8. So we draw a horizontal line and remains constant. Remember, it remains constant, it is not changing. So we chose some point, some position it is not given, so we can choose any suitable place for 9.8. So let's say this is 9.81 meters second minus 2, and then you draw a horizontal line starting from 0 till t3. So that's how you draw acceleration time graph for bouncing ball. Ignoring, remember, this is graph when you ignore the time of impact. 17. A student is investigating a spring. He uses the steel disc shown in the diagram. So diameter 0.12, 0.03 thickness. Show that the weight of the disc is about 26 Newton. Density is given. So we know that density D or rho is given, and we need to find what weight. Okay, so weight is mg. We don't have mass, but we have density, and we can figure out volume because this is a cylinder. So we have a formula for volume of cylinder. So we can use that. This mass can be replaced with rho vg, because remember, density is mass over volume, and mass will be density times rho. So mass can be replaced with density into rho into g. So just substitute all the values. So rho is 7900 times volume, and volume is the volume of this disc, and this disc is the shape of cylinder. So remember, volume of a cylinder is pi r square L, or you can say pi r square h, where r is the radius and L is the thickness. So in this case, this is your thickness or length or height, whatever you say, and this is your diameter, and radius can be found from diameter. So pi is 3.14 and r square is d by 2, which is 0.06 whole square, d by 2 here, and L is the thickness, so 0.03. Once you solve this, so W would be equal to 26.29. You can round it off, 26.3 Newton. This is how you find the weight. You can find individually, you can find first mass separately and then use mg. It's up to you. So this is the weight, 26.3 Newton. Okay. Part B, the student drops the disc from a height of 0.3 meter on to a spring. The original length of a spring is 0.11 meter. The maximum compression of the spring when the disc lands on it is 0.06 meter. Okay, so calculate the change in gravitational potential energy of the disk between when the disk is released and when the spring has maximum compression. Okay, so we need to find change in gravitational potential energy. The idea is we know that the height from which the disk is released, and the original height of the spring is given, which is 0.11 meter here. And then when the disk lies or compress the spring, I'm just assuming it is compressed. So this compression, the maximum compression, I am assuming this compression is 0.06. So 0.06. That means if we need to find the change in gravitational potential energy, so we need to figure out this height. This is height, change in height of the disk. And this delta H is this height. Let's call it H1 and H2. So H1 plus H2 will give us this delta H. And this H1, indeed, it is 0.3 minus 0.11, which is 0.19 meter. So now you can say that change in gravitational potential energy, delta GPE, is mg delta H. You can draw these thing on your diagram so that examiner can see what are you doing. So mg is delta H, and again m is mass of the disk that we found. Oh, mg, don't need to use mass because mg is the weight. So this mg is the weight. So 26.3 delta H is sum of these two heights, so 0.19 plus 0.06. So delta GPE will be 6.575, or you can round it off 6.6 joule. This is gravitational potential energy, change in gravitational potential energy. Hence, calculate the maximum force that disk exerts on the spring at maximum compression. A straightforward question. We have energy stored that we found in the previous part B, which was energy was 6.6 joule. So we can use this energy to figure out maximum force. So E is equal to half of Fx, where F is the force, deforming force or external force, and X is the extension. So F will be 2E divided by X. So twice of E is 6.6 divided by extension, and extension is 0.06. This is the extension. So the answer will be equal to 220 Newton. This is the maximum force. Hence, determine the stiffness of the spring. Stiffness is nothing but K, spring constant, and you know that F is equal to Kx. So K is equal to F upon X. So F is 220 divided by extension 0.06. So answer will be equal to 3666.66. You can round it off and you can say it is 3.7 10 to the power 3 Newton meter minus 1. So this is your stiffness. Question number 18. Kevlar is a modern lightweight material. Due to its physical properties, Kevlar is being reused to replace nylon and steel in many applications. The stress strain graph for Kevlar, nylon, and steel are shown. These are three graphs: nylon, steel, and Kevlar. When pulling a heavy load, Kevlar cables are now often used instead of nylon cables. Explain two advantages of using Kevlar in cables compared to using nylon. If you see the graph, it is clearly shows that Kevlar has high stiffness. So high stiffness or large stiffness means high gradient. Of course, it has a high gradient. So stiffness is higher. Stiffness higher mean, so for Kevlar, you can say that Kevlar is stiff. That means a large force, a large force needed or applied for a small extension. For a small extension. So it will not be extended much if the large force is applied. This is the one advantage. Or you can say the Young modulus is also higher. Moreover, if you see the breaking stress, the breaking stress for Kevlar is very, very high compared to the breaking stress of the nylon. That means Kevlar is stronger than nylon. So you can compare breaking stress and the stiffness. This is one most common comparison. The photograph shows a machine used for surveying the seabed. A communications cable connect the machine to a ship on the surface. This is the communication cable. The material used in the outer casing of the communication cable must withstand the large pressure at the seabed, yet be light enough to lift out of the water. Density of Kevlar is 1400 kg per meter cube. Density of steel 7800 kilogram per meter cube. Deduce whether steel or Kevlar is more suitable to use in the outer casing of communication cables at the seabed. Indeed, if you see the density of the Kevlar is quite less than the density of the steel. That means Kevlar is lightweight. Kevlar is lightweight. Even it is stronger than the steel because it has a high breaking stress. If you compare the breaking stress of a steel, so it is lightweight and stronger due to high stress and the density. So that means a very thin coating can be used as a coating, so for the same amount of stress, and it will be lightweight. So for the same amount of stress and pressure, Kevlar is best because of the lightweight and the stronger than the steel. Due to effects of earth thrust, the apparent weight of a cable is in seawater is less than it is in air. Calculate apparent weight of a sample of Kevlar of volume this much in seawater. The density of water is this. So situation is, that you have a Kevlar, and if it is in air and ignoring air resistance, so on Kevlar sample, if this is a Kevlar sample, something like this, it will be experiencing only weight, ignoring air resistance. But if you put same Kevlar sample in water, so inside water or in water, whatever you say, the same Kevlar will be experiencing other upthrust other than weight. So due to upthrust, some amount of weight is cancelled or balanced, and the rest amount of weight is experienced there. So we have some apparent weight due to this upthrust. So this apparent weight W dash, suppose just a symbol, will be equal to W minus U. That's what we need to do. That means we need to find weight of the Kevlar and the upthrust acting on the Kevlar. So let's just find first weight. So weight of the Kevlar is W equal to mg. Again, we don't have mass, we have volume of the Kevlar sample and density in a previous part. So mass is cannot be found. So but we have a density. So density was, if you see the previous part, it was 1400 for Kevlar, and volume, because again I'm using same approach, mass is equal to density into volume. So 1400 is the density and the volume is given 8.5 into 10 to the power minus 3. This is because this is the mass of the Kevlar into G, 9.81. And if you solve this, so mass of the uh, weight of the Kevlar will be 116.8 Newton. And now let's just talk about upthrust acting. So upthrust is equal to rho Vg. Remember, in this case, this rho is the density of seawater, because in upthrust we use density of fluid. So again, density of seawater is 1030. V is the volume of displaced fluid or volume of the sample of the object immersed in the fluid. And in this case, this V is as same as volume of the Kevlar. So 8.5 into 10 to the power minus 3 divided into 9.81. And this upthrust, you will have 85.9 Newton. And the apparent weight W dash is equal to W minus U. So your final answer will be 30.9 Newton. Question number 19. A yo-yo is a toy that consists of two connected discs on a piece of a string. This is a yo-yo. A child stands in a stationary train holding a yo-yo. The train accelerates and the string moves into the position shown at an angle theta to the vertical. So this is the child standing holding yo-yo, standing in a stationary train. Of course it should be vertical because train is not moving. As train accelerate in the given direction, the new position of the yo-yo is shown here with angle theta. So train is accelerating here. So draw a free body diagram of for the yo-yo. So you know that this is the yo-yo. Weight of the yo-yo is acting downward. Weight always acting vertically downward. And because yo-yo is attached with the string, then we have a tension acting in the string here. This is T. That means these are the two forces will be acting on our yo-yo. So here we have a free body diagram, and then you can plot these two forces in given direction. So this is the weight acting down and tension acting in this direction. Calculate the acceleration of the train by resolving horizontally and vertically for the forces on the yo-yo. Mass of the yo-yo is this, theta is 8 degree. If you see free body diagram, which is this is the yo-yo, and you know that you drew W downward and the tension would be in that direction. This is T, and we were given angle of 8 degree. So if I draw a normal line, something like this, it's just a vertical line, just to mention. So this is theta given in the previous diagram. So we need to find acceleration of the train. And remember, if you see the diagram, acceleration train was moving rightward. And why do we have a rightward acceleration? If you see the overall situation, we say that we have two forces, but T can be resolved into its component. And if you resolve, so for T has two component, one is rightward component like this, and the one is upward component or vertical component, this acting upward. So now if you see this angle is theta, that means the vertical component will be t cos of theta, and this horizontal component here will be t sine theta. Most of the time I some most of the time my students keep asking me, sir, how do we know which one is sine and which one is cos? This is most common confusion. Generally what happen, students keep thinking that horizontal is sine, horizontal is cos. I'm just changing the color. So most of the time they say that the horizontal is cos and vertical is sine. So most of the cases this is true, but not always. So instead of in confusing with the horizontal and vertical, I always say that instead of memorizing horizontal and vertical, you memorize, or you say adjacent and perpendicular component. It is better way to avoid the confusion of sine and cosine. So the side adjacent with the given angle is adjacent is always with cos, always with cos. And perpendicular or opposite component is always with the sine. There will be no confusion at all then. Like in this triangle, so this green line, instead of saying horizontal component, I would say opposite component, and opposite component always comes with sine. And the vertical one, which is in this diagram vertical, but instead of saying vertical component, I would say the adjacent component, adjacent to the angle. That's why it always comes with cos. So if you know if you say adjacent and opposite component, this confusion will just go on, and then you will never be confused again with sine and cos, these kinds of stuff. So now let's come to the point. So we need to find the acceleration, and we know that if you see the t cos theta is balancing w, but t sine theta, this is the only force that is acting on rightward. That means t sine theta is basically a resultant force. So you say that t sine theta is equal to ma. You can figure out acceleration if you have mass, which is given, theta, it is also given 8 degree, but we don't have t. So in order to find acceleration, first we need to find tension. So I'll just call this equation number 1, and we try to figure out tension first. So for tension, we use the vertical component. So we know that T cos theta acting upward and W acting downward. So you say that T cos of theta is equal to W, which is equal to mg. Now clearly everything is given, so we can figure out T from here. So from here T is equal to mg cos of theta. You substitute the value here. M is 0.05, and then g 9.81 divided by cos of 8 degree. So T would be equal to 0.495 Newton, and this T can be used in equation number 1 to find acceleration. So now acceleration would be equal to T sine theta divided by M. So T is 0.495 times sine of 8 degree divided by m is 0.05. So acceleration you will find here 1.377. 1.377, you round it off, acceleration is equal to 1.4 meter per second square. This is the acceleration. In fact, this question can be done in another way. I will just show you a quick way. And I guess I have in some of my previous video I told you that whenever you have two equation in terms of sine and cos, so we can simplify this and we can make these equation in terms of tangent theta. So you can divide these two equation, to make tangent theta, and you see that the equation will be so simple to find your answers. So we divide t sine theta with the cos theta. So left hand side, t sine theta divided by t cos theta is equal to ma divided by mg. And you know that the benefit of dividing this is you can cancel these t, so don't need to find t, don't need to waste time here. So t is gone, so sine theta upon cos theta is tangent theta, and on the right hand side you can see that is gone, so a upon g, and then a is equal to g tangent theta. You just use value of g, and theta is equal to 8 degree, and you will have same answer as you find 1.377 or 1.4. So 1.4 is round off values. Part C, discuss whether the string could ever become completely horizontal or completely vertical while the train is accelerating. So remember, when train is accelerating, that means there is some accelerating. So in yo-yo, there must be some acceleration in a horizontal direction, and this acceleration is coming from you if you recall the diagram, this horizontal force is coming from t cos theta. So t cos theta is always there, the horizontal component. So that means due to that horizontal component, the string can never be vertical because it always acting. So it cannot be, a string cannot be vertical, something like that, because of this existence of t cos theta. Moreover, for yo-yo in a vertical direction, you know that the vertical component t is acting and w is pulling it down, and they are balancing. So because we have a vertical forces acting on the yo-yo, so the yo-yo can never be horizontal, so it can never be horizontal. So both of the condition, horizontal and vertical, not possible because of these two scenario. One is existence of presence of a horizontal force and these vertical forces. So that's how you can explain. Thank you very much. I hope you understand. See you in the next video. Have a nice time.